The question is, a toy car with charge Q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Due to the force QE, its velocity increases from 0 to 6 meter per second in 1 second duration. At that instant, the direction of the field is reversed. The car continues to move for 2 more seconds under the influence of this field. The average velocity and the average speed of the toy car between 0 to 3 seconds are respectively. The solution is, in order to answer this question, we must first initially draw the diagram to understand the movement of the toy car. Now, initially, at t equal to 0, we have v equal to 0, and at t equal to 1, the velocity is 6 meter per second. Also, at t equal to 2, the direction is reversed, and at t equal to 3, the velocity is minus 6 meter per second. Now, the acceleration will be delta v upon t, that is 6 minus 0 upon 1, giving us acceleration as 6 meter per square. Now, for t equal to 0 and to t equal to 1 seconds, the initial distance s1 will be half at square, that is half into 6 into 1 square, giving us 3 meter. Now, for t equal to 1 to t equal to 2 seconds, the distance s2 will be ut minus half at square, that is 6 into 1 minus half into 6 into 1 square, giving again 3 meter. Similarly, for t equal to 2 seconds to t equal to 3 seconds, we get s3 as minus 3 meter. Therefore, the total displacement will be s1 plus s2 plus s3, giving us 3 meter. So therefore, the average velocity will be 1 meter per second and the total distance traveled will be 9 meter. So the average speed will be distance upon time, that is 9 by 3 equal to 3 meter per second, giving us the solution as option 4.